guys, I just want to make a quick video for you here about ratios and rates and conversions. We're going to jump into percentages pretty soon, and a lot of that is dealing with ratios or starting with ratios. So this might be a little bit of review, hopefully some stuff you've seen in middle school and you'll see in science, but we just want to do a little practice with our conversions, and then we'll move on to percentages. So your learning target is 2G. We'll use the same learning target for a few days. I can create and solve equations involving percentages. So our first example here is just saying convert the amount that you're given, so in this case 15 days, to the given unit, right? So the different values are called units. This is called dimensional analysis, technically, when we actually are converting from one thing to the next. So when we are looking at this here, we have to think about what's our conversion factor, okay? And so when we create a conversion factor, it's something that will change the first unit, days, into the second unit, hours. So it needs to be something that can compare these two things. And so it's going to look like a fraction, right? We're essentially making fractions that are equivalent to 1. They're just in different units, right? So we know if we had a fraction like 5 divided by 5, well, that's equivalent to 1, right? This fraction is actually a ratio, just a comparison of two things. That's all a ratio really is. And the fraction that we're going to use here is that, okay, well, hours and days are what we're working with, so we need both hours and days in our fraction. And I know there are 24 hours in one day. Now, it's important that you keep those units there. Keep labeling the units because we want to be able to cancel those out just like we would a number, okay? So one of the important things is that the unit we're looking for, if it's just a basic conversion, the unit that we're looking for should be in your numerator, okay? So if I want to convert to hours, I want the amount of hours to be in the numerator. And then that means the thing that I want to get rid of is going to be in the denominator, okay? So let's watch how this works, and then I want to show you maybe an alternative route. So, and I know some of you guys are like, man, I can do this in my head, but some of these are a little tricky and you might not be able to do them in your head. So that's where this sort of process is helpful, okay? So right now we're starting with 15 days, right? And treat days like it's its own variable, okay? So it's like 15 times days, and that's over 1 if we want to make it into a fraction. Now to convert, I'm going to multiply by 1, so I'm not actually changing the value of 15 days, I'm just writing it in a different way, right? Just like we can make equivalent fractions, 5 over 5 is equal to 1, well that would be the same thing as 10 over 10 or 20 over 20. Those are not the same number every time, 20, 10, 5, but it's the same value, okay? So 15 days over 1 is what I'm starting with. I'm going to multiply that by 24 hours. Again, treat hours like your variable, and over 1 day. Now, if I had a fraction like let's make it 15. 15x times 24y divided by 1x, right? Anytime we have two things that are the same in a fraction, we can cross cancel, so the x's would cancel out there. Well, that's exactly what's going to happen with your days, right? The days could cancel here and here. Just like when we're solving an equation, if anything is being divided by itself, it cancels out, all right? So what we're left with is 15 times 24, and the only unit we have left is hours, right? So 15 times 24 would give us, hold on, I don't know, 360 hours, okay? So that's one way we can convert. you don't always have to use this exact ratio, right? 24 hours in one day. I picked that because 24 and 1 are both whole numbers, and that keeps the hours and days where I want them. But if, let's say I still wanted hours on the top and days in the bottom, right? But maybe I wanted to write it in terms of 1 hour, all right? So, well, I could write days then. 1 hour is equivalent to 1/24 of a day, right? The day chopped into 24 pieces. That doesn't look quite as simple to me because now I have a fraction in the denominator, so it's making it a little more difficult, all right? So in math, I always try and go with the easiest route, and this 24 hours in one day looks simpler to me, but sometimes, as you'll see in the next problem, it really doesn't matter which one you pick, okay? And I do want to note here, you don't need to memorize the conversion units. You can look them up. We live in the 21st century. I don't memorize how many meters are in a foot, okay? I don't know that. I know approximately, but not exactly, right? So that's something you can just Google. I don't expect you to know those things off the top of your head, okay? So make that note. You don't need to memorize those conversion units, okay? So then the next thing we want to work on is 15 meters to feet, okay? So what I've done on the right-hand side, I've given you two conversion factors. You could use either one, whichever looks simplest to you. It's important to note that because I'm converting to feet from meters, that meters is going to go in the denominator and feet goes in the numerator, both times, okay? I want you to pause the video, see if you can convert, come back, and we'll check out and see if we got it right. So, oops. Okay, so hopefully you've had a chance to try it. Now let's check it out. So 15 meters is what we're starting with. The abbreviation for meters is just M. I always use the abbreviation when we're doing the actual calculations, simpler. I'm going to multiply that by, and again, I could choose 1 foot over 0.3048 meters or 3.2808 feet in 1 meter. I usually like to go for the larger numbers, so I'm going to use 3.2808 feet in 1 meter. Again, these two things, this is like multiplying by 1 because they're actually the same value. Different numbers, same value. All right, and we can put 15 over 1 if we want to. Now remember to cross cancel. Any units that are the same and they're ones in the numerator and ones in the denominator can be canceled out. So meters cancel with meters, and I end up with 15 times 3.2808, and feet is the only unit I have left. All right, I believe that gives us 49 point something. 49.21 feet. All right, hopefully you got the same thing. Again, if you used this up here, it would be 15 meters over 1 times 1 foot over 0.3048 meters. Meters still cancel out. You get 15 feet divided by 0.3048. Doing that division, you should still get the same answer. Oh, that was a wonky arrow. All right, so you can convert either way. Same idea for pounds to grams. Again, there's two conversion factors I gave you over here. There's 453.6 grams in a pound, or in 1 gram, there's 0.0022046 pounds. Again, I usually like to use the larger numbers because I feel like it's more accurate. So I would probably go with that first conversion factor, but same process. So we'd have 15, abbreviation for pounds is LB or LBS over 1 times, this time 453.592 grams. Put that in the numerator because that's what I want to end up with, over 1 pound. Right? Pounds cancel out, and I get 15 times 453.592 is 6803.9 grams, okay? So those are some different ways you can convert, all right? We'll practice this a little in class. The other thing I wanted you to have at the ready, you only need to write these down if these are things you don't commonly know, but are some abbreviations in case you're working and you're like, what the heck does MG mean, or OZ, or YD? So if you want to write some of these down here, you can pause the video and jot these down. Again, I won't read you all of these because I know you can read or look them up, but it's helpful just to think about them in their different units. So for time, we have hours, minutes, seconds. For length or distance, inches, feet, miles. If you know the conversion factors, that's also great. Most of you guys know 12 inches in a foot, 5,280 feet in a mile, but you might not know how many centimeters are in a kilometer or how many yards in a mile or something like that. Those are still things you could look up, okay? Weight, we can weigh things kilograms, grams, milligrams, pounds, ounces, tons. And then finally, volume measurements like quarts, cups, ounces, gallons, liters, milliliters, pints. There are more than what I've listed here for sure. I just wanted to give you like a basic overview, okay? So if you want to, pause the video, jot down these and the ones that were in the video previously, and then move on to example 2. So car 1 drove 408 miles in 6 hours, and car 2 drove 365 miles in 5 hours. During their cross-country road race, who had the fastest average speed? So when we did literal equations, we talked about distance is equal to the rate times time. For our purposes, rate and speed can be synonymous, okay? So if I want to find the rate or the speed, we have to get that alone in our equation. So if our formula is D equals R times T, well, to undo multiplication, I would divide by T on both sides, right? T's would cross out. So the rate or the speed is equal to the distance divided by the time, okay? And this is, again, a ratio. So for car 1, we want, to get the speed, we want to do distance divided by time. Well, car 1 drove 408 miles, and they did that in 6 hours, right? Now let's actually divide that to find out what our value would be. And we would get 68, and then again, look at your units, miles over hours. So that's, we could write that as miles over hours, or we could say 68 miles per hour, mph, right? So that would be the average speed for car 1. Of course, it can fluctuate, but if we just take at the very basic level how far they went and how long it took them, tells us how fast they were obviously going. And car 2 is moving 365 miles in 5 hours, right? So if I divide those two, I get 73, again, mph, or you could write it as miles over hours. So who had the fastest average speed? Car 2 had the fastest average speed, okay? So we can do some comparisons. And the last thing I want to look at is when we have to convert a ratio in itself, right? So miles per hour in the one problem we just looked at. In this case, they're asking us to convert 25 miles per hour to meters per minute, okay? So we have to do 2 conversions. We have to convert 25 miles per hour into 25 meters per hour, And then we want to take that, and we're still going to then change the hours into minutes. Okay, so one step at a time here. So first step is to convert miles to meters here. Okay, so 25 miles per hour. We're going to multiply that by, there's 1609.344 meters in 1 mile. We talked about what can happen if the units are across from each other. Those miles will cancel. So we need to do 25 times 1609.344, and that gives me 40,233.6, and the units I have left in the numerator is meters, which is what I wanted, and the denominator is hours. Okay, so because I wanted meters in the numerator, I had to put meters in the numerator of my conversion factor. All right, now we're going to take this answer that we got, and we're going to use that in the next problem. Okay, now I need to convert these hours into minutes, and because I want to change the denominator, when I make my conversion factor, I want to put what I want to end up with, so minutes, in the denominator. All right, so we start with 40,233.6 meters per hour, right? And we're multiplying that by this conversion factor. In 1 hour, I can travel 60 minutes. All right, so the hours cancel, and we're left with meters over minutes, which is what we want. But now because 60 is in the denominator, now we have to divide. So it's 40,233.6 divided by 60. That would be 670.56. And again, meters in the top, minutes in the denominator. It's really important that you guys try and also think about, does this answer make sense, right? You know, so when you go from miles to meters, well, meters are a lot smaller than a mile. So having that conceptual understanding of how long or how large these units are is also helpful. It makes sense that there should be a lot more meters than there were miles, right? So that would be my final answer, but again, just doing it in 2 steps. All right. So go ahead and submit a copy of your notes to this assignment, and we will practice it in class.